Basic electronic components. Resistor types. Resistors limit current flow in a circuit. Types include fixed resistors, which have a fixed resistance value, and variable resistors like potentiometers, which allow adjustable resistance. Capacitor types. Capacitors store and release electrical energy. Types include ceramic capacitors, which are commonly used for high-frequency applications, and electrolytic capacitors, which have higher capacitance values but are polarized. Inductors. Inductors store energy in a magnetic field and oppose changes in current. They are used in filtering and tuning applications. Diodes. Diodes allow current to flow in one direction only. Zener diodes are used for voltage regulation, while LEDs emit light when forward biased. Transistors. Transistors, such as BJTs, act as electronic switches or amplifiers, with NPN and PNP types controlling current flow in circuits. Field effect transistor. FET. FETs control the flow of current by applying voltage to the gate, with MOSFETs being widely used for switching and amplification. Photodiodes. These diodes generate a current when exposed to light, used in optical applications such as light sensors. Optocouplers. Used for isolating different parts of a circuit, optocouplers transmit electrical signals through light to maintain electrical isolation. Rectifiers. Diodes are used in rectifier circuits to convert AC to DC power. Half-wave rectifiers use a single diode, while full-wave rectifiers use two or more diodes to convert both halves of the AC wave. Thermistors. These are temperature-sensitive resistors. Negative temperature coefficient, NTC, thermistors decrease resistance as temperature increases, while positive temperature coefficient, PTC thermistors, increase resistance with higher temperatures. Diode circuits. Basic diode theory. Diodes allow current to flow only in the forward bias condition, positive to anode, negative to cathode, and block current in reverse bias. Rectifier circuits. Half-wave rectifiers use a single diode, while full-wave rectifiers use 2 or 4 diodes to convert AC to DC. Bridge rectifiers are common in power supply circuits. Clipping circuits. These circuits limit the voltage level by cutting off, clipping, the waveform at a certain threshold. They are used in waveform shaping and signal protection. Clamping circuits. These circuits shift the voltage level of a waveform, often used to set a baseline voltage or eliminate negative swings in a signal. Zener diode. Zener diodes are designed to operate in reverse breakdown, maintaining a constant voltage over a wide range of currents, commonly used for voltage regulation. LEDs. Light-emitting diodes emit light when current flows through them. They are widely used in displays, indicators, and backlighting. Diode applications. Diodes are used in signal detection, power rectification, voltage regulation, and in communication systems as modulators or demodulators. Field effect transistor circuits. JFET characteristics. The junction field effect transistor, JFET, is controlled by the voltage at the gate, with current flowing between the source and drain. The gate is reverse biased, and the drain current depends on the gate source voltage. MOSFET types. MOSFETs, metal oxide semiconductor field effect transistors, are commonly used for switching and amplifying. They come in two types: enhancement mode, normally off, and depletion mode, normally on. MOSFET operation. The MOSFET operates by creating a conductive channel between the source and drain, controlled by the voltage applied to the gate. Common source amplifier. This configuration is used for voltage amplification, offering high gain and moderate input/output impedance. Common drain amplifier. Known as a source follower, this amplifier offers low output impedance, making it suitable for impedance matching. Common gate amplifier. This configuration is used in high-frequency applications, providing low input impedance and high output impedance. FET biasing. FETs are typically biased using resistors and voltage sources to ensure they operate in the desired region, e.g., pinch-off region for MOSFETs. FET applications. FETs are widely used in low-noise amplifiers, RF applications, and for voltage-controlled resistors in analog circuits. Oscillators. Sinusoidal oscillators. These oscillators generate sinusoidal waveforms, commonly used in radio frequency, RF, and audio applications. Examples include the Colpitts, and Hartley oscillators. Relaxation oscillators. These are used to generate non-sinusoidal waveforms, typically square or sawtooth waves, and are used in timing and clock applications. Crystal oscillators. Crystal oscillators use a quartz crystal to generate a highly stable frequency. They are widely used in clocks, radios, and GPS systems. Phase-locked loop, PLL. APLL is used for frequency synthesis and synchronization, often used in communication systems for modulating and demodulating signals. Communication circuits. Amplitude modulation, AM. AM is a technique where the amplitude of a carrier wave is varied in proportion to the modulating signal, commonly used in radio broadcasting. Frequency modulation, FM. FM involves varying the frequency of a carrier wave according to the input signal, commonly used for higher fidelity radio broadcasting. Phase modulation, PM. In PM, the phase of the carrier wave is varied in response to the input signal. Pulse code modulation, PCM. PCM is a method used to digitally represent analog signals by sampling and quantizing the signal into discrete values. Frequency division multiplexing, FDM. FDM involves dividing the available frequency spectrum into smaller subbands, each carrying a different signal, widely used in telecommunication systems. Time division multiplexing, TDM. TDM divides time into discrete slots and allocates each slot to a different signal, allowing multiple signals to share the same transmission medium. Modulator and demodulator circuits. These circuits modulate an input signal for transmission and demodulate received signals back to their original form. Wireless communication. Modulation techniques. Modulation refers to varying a carrier signal in accordance with the information signal. Common techniques include amplitude modulation, AM, frequency modulation, FM, phase modulation, PM, and more advanced schemes like quadrature amplitude modulation, QAM, used in digital communications. Antennas. Antennas are used to transmit and receive electromagnetic waves. Types of antennas include dipole antennas, loop antennas, parabolic antennas, and patch antennas, each suited for different applications in wireless communication systems. Radio frequency, RF, communication. RF communication involves transmitting data over radio waves. RF systems are used in cellular networks, Wi-Fi, Bluetooth, and satellite communication, with frequencies ranging from a few MHz to several GHz. Wireless networking. Wireless networks connect devices without physical cables. Technologies include Wi-Fi, Bluetooth, Zigbee, and 5G, each with specific use cases for short-range or long-range communication, high-speed data transfer, and IoT applications. Spread spectrum. Spread spectrum is a technique used in wireless communication to spread a signal across a wide frequency band, increasing resistance to interference and improving security. Techniques include direct sequence spread spectrum, DSSS, and frequency hopping spread spectrum, FHSS. Microwave communication. Microwave communication uses high-frequency radio waves, typically 1 GHz to 100 GHz, for point-to-point communication, including satellite links, radar systems, and high-speed data links. Wireless protocols. Wireless protocols define how data is transmitted in a wireless network. Examples include IEEE 802.11, Wi-Fi, IEEE 802.15, Bluetooth, and Zigbee, each with different features for data rate, range, and power consumption. Power electronics. Power diodes. Power diodes are used to control the flow of current in high-power applications, such as rectifying AC to DC power. They are designed to handle higher voltage and current than regular diodes. Thyristors. A type of semiconductor device used for switching and controlling large amounts of power. Thyristors include SCRs, silicon-controlled rectifiers, and triacs, commonly used in motor control, lighting, and power regulation. Power MOSFETs. Power MOSFETs are used for switching and amplifying in power electronic circuits, particularly in power supplies, motor drives, and inverters, due to their high efficiency and fast switching characteristics. IGBTs, insulated gate bipolar transistors. IGBTs combine the characteristics of both BJTs and MOSFETs, and are used in high-power applications like inverters, motor drives, and induction heating systems. DC-DC converters. DC-DC converters are used to convert one DC voltage level to another, either stepping up, boost converters, or stepping down, buck converters, the voltage, with high efficiency. AC-DC converters. These converters, also known as rectifiers, are used to convert alternating current, AC, to direct current, DC. They are widely used in power supplies and in applications where DC voltage is required. Inverters. Inverters convert DC to AC power and are used in renewable energy systems, UPS, uninterruptible power supplies, and electric vehicles. Power control. Power control in electronic systems involves regulating voltage and current levels for efficient energy use, often through feedback loops, modulation, and switching regulators. Automation and control systems. Programmable logic controllers, PLCs. PLCs are digital computers used for automation in industrial processes, such as manufacturing, controlling machinery, and managing systems like elevators or traffic lights. SCADA systems. SCADA, supervisory control and data acquisition, systems are used for monitoring and controlling industrial processes, including energy generation, water treatment, and manufacturing systems. Industrial sensors. Industrial sensors are used to measure physical parameters such as temperature, pressure, flow, and level in industrial automation applications. Motor control. Motor control systems are used to regulate the speed, direction, and operation of motors, including DC motors, AC motors, and stepper motors. These systems are crucial in automation and robotics.